MIT researchers have developed an ultra-thin loudspeaker that can turn any rigid surface into a high-quality active audio source. The straightforward fabrication process they introduced can enable the thin film devices to be produced at scale. Imagine covering your walls with squares of a thin metallic loudspeaker instead of floral wallpaper. I don't know, from a style perspective, you got the metallic speakers. It's going to be a look to it.
I think it might be a cool look.
Might be a cool look. Might not be for everybody. Mm-hmm. Compared to the floral wallpaper that they compared it to.
Right.
But the technology, maybe they can have certain different styles to fit everybody's needs.
They were thinking of lining up the car, as well, like interior. So
I have like complete
pretty immersive
360-degree audio. Paper thin.
So here's a little demo of it. Probably gonna get copyright, but here we go.
Whoa, 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 whoa. Whoa.
So it's literally just like a thin sheet of paper, and he's connecting wires to it.
Whoa. Oh my God. Lou, how?
And you can kind of tell that it's directional. So as long as it's facing you, you get the full impact.
Well, and it seems to be even louder when he bends it. Right?
Yeah,
like
it's almost
chamber.
like
yeah. Well, this reminds me to a certain extent of when we had those sound devices that you would attach to a surface or a bottle, and then the surface would become a speaker through vibration.
Yes.
I presume it has something to do with vibration. A typical loudspeaker uses inputs of electric current to pass through a coil of wire that generates a magnetic field, moving the speaker membrane that moves the air above it, making the sound we hear. This new paper-thin loudspeaker simplifies this design by instead using a thin film of piezoelectric material formed into thousands of tiny domes, only a few hair widths across, that vibrate individually when voltage is applied over them in a phenomenon called the inverse piezoelectric effect. The engineers use a laser to cut tiny holes into a thin sheet of PET, a type of lightweight plastic, the underside of which they laminated with a thin film of PVDF by applying a vacuum above the sheets and a heat source 80 degrees Celsius underneath. The pressure difference caused the thin PVDF layer to bulge through the tiny holes, forming domes. Wow.
Very cool. I mean,
Wow.
you don't get the low end, but I mean, it seems pretty clear.
Yeah, I wonder if there's a solution for the low end. But certainly, you can see all types of applications for this paper-thin audio. I don't know. The cost is probably prohibitive at the moment.
They say that, it's expensive to make, but apparently the whole electric running this thing is pretty inexpensive.
Inexpensive, yeah. Hey, man.
Pretty inexpensive.
I thought you were,
that's a tough word.
I thought you were going to attack me there for a second.
Got my fangs out? Yeah. But cool stuff, nonetheless.
Very cool.
Definitely. And it's one of those things of scale. If they can figure out a way
Right.
where it's useful in some sort of application, some sort of common application, and make a lot of it, then that cost of manufacturing can go down, right? They can create all sorts of special tools like Ford to do a better job of making those things for less.